Hello and welcome. In this video, we're going to be looking at the calculations necessary when you are trying to prepare a solution of known volume and known molarity. Before we get into those calculations, let's talk real quick about what a solution actually is. Okay? When you're looking at a solution, you've got two parts. You've got what is called the solute, which is the substance that actually dissolves. And then you have something called the solvent, which is the substance in which a solute dissolves. Okay, so if we take the example of salt water, we all know that if you take a sample of salt, put it into water, the salt dissolves. So when we're looking at that example of salt dissolving water, salt is going to be considered the solute because it is the substance that dissolves. Water is going to be considered the solvent because that is the substance into which the solute dissolves. Okay. Now, the other aspect of a solution is its strength or concentration. So if we take that salt solution, the amount of salt that we put into it, that we dissolve into that solvent, determines how strong that concentration is. And in chemistry, we measure concentration in terms of molarity. Molarity is symbolized by capital M, and it is indeed just the concentration or strength of a solution. As far as calculation wise, when we're looking at molarity, molarity equals the moles of solute divided by the volume of solution, okay? Not the volume of solvent. So when we prepare a solution, we are going to mass out a specific amount of solute, put that into a beaker or a volumetric flask, and then we're going to add water to get it to dissolve, and then finish filling up, typically the volumetric flask, to the final volume. Because even when something dissolves, it still takes up space. Many people think that when salt dissolves, it just kind of disappears and no longer takes up space. And that's not the case. It still takes up volume. And that's why within molarity, we're dividing by the volume of solution, the total volume of solution that includes the volume that the solute takes up and the volume of the solvent. So when we actually calculate molarity, volume is traditionally done in liters. Now, you can do molarity in terms of milliliters, but then we call it millimolality. And we can even take this equation of molarity equals moles divided by volume of solution, rearrange it for the moles of solute, which would give us moles of solute equal molarity times the volume of solution. And again, if we do volume in terms of liters, we get moles. If we do it in terms of milliliters, we would get something called millimoles. But for this video, we're going to go on and do this in terms of liters for our volume. So overall, this is the way that the equations look when we're using the symbols. You've got molarity equals moles divided by liters. And when we rearrange by multiplying both sides by the volume or liters, we end up with moles equals molarity times liters. So we are going to look at a question here in just a moment, but this is the key thing. If you know the moles and the molar mass of a substance, you can calculate grams. So we're going to look at this problem that asks us to prepare or calculate the grams necessary to produce a 200 milliliter solution of a 0.6 molar NaCl solution. So we can take that volume, convert it to liters, multiply it by that molarity to find the moles of NaCl, and then using molar mass, we can calculate the grams of salt that we're going to need. So let's go on and do those calculations. So this is the problem. How many grams of NaCl are needed to prepare 200.0 milliliters of a 0.6 molar NaCl solution? So first thing that we always want to do is identify what the question is asking. In this case, it's how many grams in the substance of NaCl. Secondly, we want to look at what is given. So we have 200 milliliters, that is a volume, and 0.6 molar, that is our molarity. So again, looking at the equation that moles of solute equal molarity times volume, we need to take this volume and first off convert to liters so that our units will cancel properly. So that's the first thing I'm going to do, 200.0 milliliter. And in a conversion factor, because we're starting with milliliters, we need milliliters in our denominator so that they will cancel out. And then we will need liters in our numerator. And hopefully you already know that there is 1 liter per every 1,000 milliliters. And in converting, we always multiply by what's on top, divide by what's on bottom. And in doing so, again, our units of milliliters cancel to leave us with liters. And when we do this math, 200 times 1 divided by 1,000, you would get the answer of 0.2000 liters. And the reason I'm leaving all these zeros is because in our starting amount, we have 4 significant digits. So we need to make sure we have 4 significant digits in our final answer. So we have 0.2000 liters. Now that I have that volume, we can look back at this equation that moles equals our molarity times our volume in terms of liters. So that leads us to moles, in this case of NaCl, our solute, are going to equal the molarity of 0.600 molar times the volume of 0.2000 liters. And as far as units, remember that molarity really is units of moles per liter. So again, we end up with liters in our numerator, canceling out the liters in the denominator to give us the proper units in the end. When you solve this out, you get 0.120, and that will be moles of NaCl. We're now looking at 3 significant digits because that's how many my molarity had. And when you multiply, you always base your answer on the fewest number of significant digits. So now that I've got my moles of NaCl, I can take those moles of NaCl, 0.120 moles of NaCl, and I can convert that to grams. To convert to grams, again, because I'm starting with moles, I want moles in my denominator. I will want grams in my numerator. And we need the molar mass, because again, if you know the moles and the molar mass of a substance, you can calculate those grams. So to calculate the molar mass of NaCl, sodium, I have one of those times its molar mass of 22.99 grams per mole, which we find that value from the periodic table. We have chlorine, 1 chlorine with its molar mass of 35.45 grams per mole. Again, we find that mass from the periodic table. So once we multiply 1 times 22.99 and 1 times 35.45, we would add up those values and we'd find 58.44 grams. Again, in this case, we're dealing with sodium chloride. So it'd be that many grams of sodium chloride per every 1 mole of sodium chloride. And this is the conversion factor that I will now use to convert those 0.120 moles of NaCl over to grams. So if I'm looking at this value, I've got my 58.44 grams divided by 1 mole. And when you do that math, you will get 7.013. And then again, we need to round to just 3 significant digits. So 7.01, and then units of grams NaCl. And that is the mass of NaCl that we would need to have to be able to prepare this solution. So here's what's going on. We would now go into lab. We'd get our salt. We'd have a balance. We'd have a weighing dish. We would mass out this 7.01 grams of NaCl, put that into a volumetric flask, where that volumetric flask holds just the 200 milliliters of total volume. Add enough water into that volumetric flask and swirl to dissolve that salt. Once the salt is dissolved, we'd finish adding the water into the volumetric flask until we have a total final volume of 200 milliliters. And in doing so, dissolving the 7.01 grams into a final total volume of 200 milliliters, we would have our 0.60 molar solution. So hopefully all that made sense. If not, feel free to leave a comment and I will get back to you. Hopefully this video has been helpful to you. Thanks. Take care.